Good morning everyone. Last video we discussed how to draw the resonance structure of different conditions like positive with the double bond, negative with the double bond, radical, lone pair and double bond cases and lone pair with the positive one. So now we are going to discuss resonance hybrid. So what does it mean? It means it is a real structure of any compound. Real structure of any compound suppose we have this one. Now you can see this compound is in resonance, so it will draw its resonance structure like this. So this is the resonance structure. So resonance structure is a imaginary hypothetical structure. This is imaginary structure. But this compound has a real structure and that is called as hybrid structure. So how to draw the hybrid structure? Look at here. In hybrid structure, the bonding and connectivity is not going to change. You can see this is 4 carbon atom and they are arranged in this system like this. Now look at the positive charge position in structure A and B. Here positive charge at this carbon and here at this carbon. So in resonance structure, the positive charge will be like this. Here delta positive and here delta positive. What does it mean delta? Delta is a partial charge. Partial charge. And look at the double bond positioning. Double bond here as well as here. So we can represent double bond by dotted line like this. This is the double bond. Dotted line. Dotted line means partial double bond. Partial double bond. Partial bond or double bond, both can be said. Clear? Suppose we have this structure and we have to draw its hybrid structure. So for hybrid you have to draw first the resonance structure. So as you can see in the last video we discussed in detail. Look at the negative charge. It will be here because head of arrow. This bond has arrow, so double bond. Clear? And now what should be the hybrid structure? So hybrid will be this. You can see here carbon has a negative, so delta negative. Here oxygen is negative in this structure. This is A, this is B. So in structure B, oxygen is negative, so again delta negative. And now look at the double bonded carbon. Here we have a double bond and here we have a double bond. So dotted will be like this, dot, dot, and then again. So this is the hybrid structure. Clear? Now the next is, look at here, resonance structure is of two types. Identical and non-identical. So look at the identical example. You can see it will donate like this and this bond is going to break this way. So it will form this structure. And non-identical is this one. Why this is identical? Look at here. oxygen is negatively charged, oxygen is negatively charged. C double bond O, C double bond O. So everything is quite same. This is first and second, and you can see they have the same thing. So whenever you have identical, it means stability will be equal. So stability of one equal to second. In this case, this carbon is negative here and here oxygen is negative. This is C double bond O, this is C double bond C. So first and second are non-identical and stability does not equal. Clear? So non-identical have unequal stability, identical have equal stability, and in the next slide we are going to cover how to compare the stability of non-identical resonance structure, which is very important. So let's talk about comparison of the stability of non-identical RS. Here we have few rules. Let's discuss one by one, and we have to apply each rule one by one. So what is rule 1? Rule 1 is more the double bond, more will be stability. More will be stability. Look at this one. This is the resonance structure of the left structure, and 1, this is 2. My question is, which one is more stable resonance structure? So answer will be this one. Why? Because it has more double bond. More double bond. Okay. So now the next rule, rule 2. Neutral compound is more stable than charge. Neutral compound is more stable than charge containing compound. Look at the example. We have to compare the stability of structure 1 and 2. So what is rule 1? Rule 1 is more the double bond, more will be stability. So they have equal number of double bond. Now move to rule 2. Rule 2 is neutral compound is more stable than charge. So this one is a neutral one because there is no charge. And this one is a charge containing compound. So first again more stable than second. Now the next is rule 3. Negative charge on more electronegative element is more stable. While positive charge on more electronegative element is highly unstable. I always told you always follow each rule one by one. So here we have two resonance structure and we have to compare which one is more stable. So rule 1 is what? More the double bond, more will be stability. So they have equal number of double bond. Now move to rule 2. Rule 2 is neutral compound is more stable than charge. So you can see they both are charge containing compound. Now next is rule 3. Rule 3 is what? Negative on more electronegative is more stable. So look at the negative charge positioning. Here negative on oxygen and here negative on carbon. Clear? And we all knew electronegativity of oxygen is greater than carbon. So second is more stable than first. Clear? Now the next is last rule, rule 4. Opposite charges closer are more stable. More stable. Look at this one. So this is their structure first, this is structure second, and this is the third one. We have to apply each rule one by one. So what is rule 1? More the double bond, more will be stability. So you can see this one is most stable. Why? Because maximum number of double bond. It has 3 double bond. So first is most. Now between second and third they have equal number of double bond. Both are charge containing compound. Both have negative on more electronegative, which is oxygen here. Now the last rule. Opposite charges closer. So this is opposite a bit close and here opposite are very far. Clear? So opposite closer will be more stable one. So first, then second, and then this is third. Clear? So I'm gonna give you some question here. Suppose this one. So here we have 4, 1, 2, 3, and this is 4th. We have to arrange the decreasing order of stability. So what is rule 1? Rule 1 is more the double bond, more will be stability. So I think first and second have rule 1. So rule 1 means more double bond, they have equal number of double bond, as you can see. Now move to rule 2. But from rule 1 it is very clear 1 and 2 are more stable than third and fourth. Now rule 2 is neutral is more stable than charge. So first is neutral. So first is the most stable. And after that second, because they have double bond. Now we have to compare 3 and 4. So rule 1 is not going to work because they don't have any double bond. Rule 2, neutral is more stable than charge. Both are charge containing compound. Rule 3, negative on more electronegative element. So here negative on oxygen and here positive on oxygen. So I told you that positive on more electronegative element or negative on electropositive element is a case of instability. So this is stable, third one, and the last one is the fourth one. Why? Because oxygen has positive charge, which means unstable. Clear? So this is the way how we can compare the stability of resonance structures. So this is all about the resonance. In resonance, we discussed how to identify. Let's look at here. In DAT, if you look at this topic, the first thing is identification, which is very important. We have done this. Second thing is pi electron. We have done this. Third thing is application of pi electron in aromatic, anti-aromatic and non-aromatic. We have done this as well. And the next one is drawing of resonance structure. We did this one as well. And the last thing about resonance is what? Stability of resonance structure. Clear? So this is very, very important, and we have done all the things. In the next video, we will discuss stability of carbocation by applying this rule, the resonance one. And then we have to discuss very small topic like the structural formula like condensed, bond line and expandable, as well as hybridization. Then chapter 1 will be over. Thank you so much for watching this.